Welcome to Unit 3, Lesson 3, Associations in Categorical Data. I can look for patterns in two-way tables and relative frequency tables to see if there is a possible association between two variables. Which value would best fit in the missing cell to suggest there is no evidence of an association between the variables? So it's important to understand what it means for there to be no evidence of an association. If there is an association, then we are saying that one of the variables seems to be linked to the other variable. One of them, it seems that depending on what one variable shows, somehow is tied to the outcome of the other variable. So here you can see along the top we have columns of digital watch and analog watch. And the rows that we have are displays the date or no date display. So in order for there to be no evidence of an association, then we would expect the proportions to be similar. Because if the proportions are similar, then it would show that it doesn't matter whether there is a digital watch or an analog watch. It should be just as likely that the watch either displays the date or does not display the date. Now, if we were to see ratios or proportions that were different from each other, then it would seem like there was some kind of association between what type of watch it was and whether or not the date was displayed on the watch. So if we want no evidence of an association, then we want the ratios or the proportions or the percentages to be similar. And so one thing to notice is that for a digital watch, 54 of them displayed the date, and for an analog watch, 27 of them displayed the date. And what might stick out to you right away is that 54 is 2 times 27. So what we might be looking for is for that missing number to be half of 18, which would be 9. Something else we could notice is that 54 is 3 times 18. So if these proportions were the same, then 27 should be 3 times 9, and it is. So by putting 9 in this missing box, we get similar proportions regardless of which way we compare the data, because the proportion of displays the date versus no date display is 3 to 1 regardless of what type of watch it is. It's also half of whatever the digital watch is ends up being our analog watch. So in this instance, 9 is the best choice of number to put in for there to be no evidence of an association. The relative frequency table shows the percentage of each type of art, painting or sculpture, those are our rows, in a museum that would classify in the different styles, modern or classical, those are our columns. Based on these percentages, is there evidence to suggest an association between the variables? Explain your reasoning. So what you need to notice is that this is a row relative frequency table because they're adding the two categories of paintings to get 100%, and they're adding the two categories of sculptures to get 100%. So, if these proportions are similar, then there is not an association because it doesn't appear to matter. If these are very different or noticeably different, then there would be an association. So what we want to look at is that you have a 41% chance of a painting being modern, and you've got a 38% chance of a sculpture being modern. And these are very similar, 41 and 38. And you have a 59% chance of a painting being classical and a 62% chance of a sculpture being classical. So basically what we would be saying is that about 4 out of every 10 paintings is modern, and about 6 out of every 10 paintings is classical. Well, we're also saying about 4 out of every 10 sculptures is modern, and about every 6 out of 10 sculptures is classical. So you seem to have just as much of a chance of being modern or classical, no matter whether it's a painting or a sculpture. So we would say there is no evidence of association. It does not seem like just because you would be picking a painting, it would be more or less likely to be modern or classical than if you picked a sculpture and it was modern or classical. You've got about the same percent chance of picking modern or classical, and it doesn't matter whether you're taking paintings or sculptures. So that is why we would say there is no evidence of association. An automobile dealership keeps track of the number of cars and trucks they have for sale, as well as whether they are new or used. Based on the data, does there appear to be an association between the type of automobile, car, or truck, and whether it is new or used? So, if we look, we could turn this into a relative frequency table. We see that cars 2 plus 2 is 4. 1 plus 2 is 3. 8 plus 4 is 12. So there are 1,234 cars. And trucks, 3 plus 1 is 4. 3 plus 5 is 8. And 2. There are 284 trucks. So the percent of new cars would be 812 divided by 1,234 times 100. That is approximately 65.8%. And the chance that a car would be used would be 422 divided by 1,234 times 100. Which is approximately 34.2%. Now, if there was no association, when we calculate these percentages for trucks, we expect them to be similar. If there is an association, we expect these percentages to be noticeably different. So the chance that a truck would be new is 233 divided by 284 times 100. Which is approximately 82%. Now we look at the percentage of trucks that are used. We divide 51 by 284 and we multiply by 100. Which is approximately 18%. So now if we're trying to decide whether or not there appears to be an association, we look at these percentages. If you're picking a truck, it's 82% chance that that truck will be new. But if someone is picking a car, it's only about 66% chance that it'll be new. Also, somebody's picking a truck, only an 18% chance that it's new, whereas with a car, there's about a 34% chance that it's used. So these percentages are noticeably different, and therefore, yes, there does appear to be an association. Because trucks are more likely to be new than cars are. This is what we mean by an association. There does appear to be a difference, and therefore there does appear to be an association. A survey is given to 1,432 people about whether they take daily supplemental vitamins and whether they eat breakfast on a regular basis. The results are shown in the table. Create a relative frequency table that shows the percentage of the entire group that is in each cell. So the important thing to know here is that we want the percentage of the entire group. So the first thing we need to do is add all of these numbers together. 384, 476, 268, and 304. They make up the 1,432 people. So when we're making the relative frequency table, we will use this number as our denominator when we're calculating the percentages. So 384 divided by 1,432 times 100. That's 26.8%. $476 divided by 1,432 times 100 is 33.2%. $268 divided by 1,432 times 100 18.7%. And finally, 304 divided by 1,432 times 100 is 21.2%. So this would be a relative frequency table. You just take each of the raw number totals and you turn them into a percentage. In this case, a percentage of the entire group. So that all four percentages add together to equal 100% of all possibilities. Several college students are surveyed about their college location and preferred locations for a spring break trip. What percentage of people who prefer to spend spring break at the beach go to a college away from the coast? So in number one, we are looking at a row relative frequency. So we need to add 37 plus 54. 7 plus 4 is 11. Carry the 1. 1 plus 3 is 4. 4 plus 5 is 9. So we want the percentage of people who prefer to spend spring break at the beach, and we want to know those who go to a college away from the coast. So we're looking in this box in the top right. We're going to divide 54 by 91 times 100 to find our percentage. That is approximately 59.3%. And number two, what percentage of people who prefer to spend spring break skiing? So again, we're looking at a row relative frequency. So we need to add 24 plus 36. 4 plus 6 is 10. Carry the 1. 1 plus 2 is 3. 3 plus 3 is 6. We're looking for those who go to a college away from the coast. So we're looking at the bottom right corner. So 36 divided by 60 times 100 will give us this relative frequency percentage. And that is 60%. So it appears that students are just as likely to go to college away from the coast, whether they prefer a beach spring break or a ski spring break. And our last practice problem, a group of people are surveyed about whether they prefer to bike or run to exercise, and whether they prefer summer or winter weather. The results are in the table. What value could go in the blank cell so that the percentage of people who like to bike and also prefer winter weather is 10%? So we want this number in the bottom left to be 10% of everyone. So if we add them together, we have 108 plus 212 plus 98. 8 plus 2 is 10. 10 plus 8 is 18. Carry the 1. 1 plus 1 is 2. 2 plus 9 is 11. Carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. So there are 418 other choices, and we need a number that if we put it into bike and winter would be 10% total. If they want the missing cell to account for 10%, that means they want the other 3 cells to account for 90%. So if we want 10%, we can take the 418 and divide that by 9. So 418 divided by 9 is 46.4. But since we're talking about people, we need to round that to the nearest whole number of people, and we could say 46. So now if we wanted to check, the 418 we already had, plus the 46 we just added. 8 plus 6 is 14, carry the 1. 1 plus 1 is 2. 2 plus 4 is 6. Bring down the 4. We have 464 total people now. And if you multiply that by 10%, you get 46.4, which rounds down to 46. So this is one way that you could solve this problem. If you have any questions about this lesson, please use class time to get clarification.